Hello viewers on YouTube. In this video tutorial, we are going to consider going through tons of examples involving finding the derivative of functions by the use of the product rule. So let's begin with example number 1. Consider the function y equals 3 plus 2x, then multiply by 1 minus x. Now the first thing first you might want to consider doing is to be sure if it is truly product rule you will need to use to simplify the derivative. Now how can you confirm that? Then you will observe that two functions will be multiplying themselves. As you can see, this is a function itself and this is also a function. And notice that they are both within the parentheses. This simply means they are multiplying themselves. So that's a good indication that you have to use the product rule to determine the y dx. So by the use of the product rule, we need to let u to be equal to the first function. Okay, that's 3 plus 2x. Then we'll let v to be equal to the second function, 1 minus x. Now the goal is to determine the derivative of u with respect to x, which in this case will be, this is a constant at 0 and this becomes 2. So that will be equal to 2. And we need to find the derivative of v with respect to x, and this will be equals to negative 1. Okay, this is a constant, and the derivative of negative x is simply negative 1. Now, from the product rule of derivatives, it says that y dx will be equals to u multiplied by the v dx, then plus v multiplied by the u dx. So therefore, the value of u is simply 3 plus 2x, 3 plus 2x, and the v dx, that gives us negative 1. So I'm multiplying by minus 1. So we are adding v, that's simply 1 minus x. So we have 1 minus x, then multiply by the u dx, which in this case we have as 2. So multiply by 2. Now we can simplify this forward. Negative 1 times 3 gives negative 3. And if we multiply by positive 2x gives us minus 2x. Now 2 times 1 gives us 2 plus 2. Then 2 multiplied by negative x gives us negative 2x. And this is that minus 3 plus 2 can be added up. And we have minus 1. And negative 2x, negative 2x gives us negative 4x. And this is our final answer. Now sometimes, depending on how your teacher or lecturer wants it, this might not be simplified, and some just be left that way. Well, most especially when you're dealing with a multiple choice question. So that is the solution to the first problem. On to example number 2. Consider the function y equals 1 minus 2x plus 3x squared, then multiply by 4 minus 5x squared. So feel free to pause the video and provide the derivative of this function. So first, have we got to use the product rule? To investigate that, we have to make sure that two functions are multiplying themselves. And you notice that that is 2 in this example. So therefore, we can go ahead. So we can let u be equals to 1 minus 2x plus 3x squared. So that's the first substitution you want to consider doing. Then we'll let v to be equals to the second function 1 or 4 minus 5x squared. Now we can now determine the derivative of u with respect to x. Now the derivative of 1 is a constant at 0. This gives us 2 and this gives us 6x squared. So left over is just minus 2 plus 6x. So that's just the derivative of u with respect to x. Okay, the derivative of negative 2x is negative 2. And the derivative of 3x squared is simply 6x. Perfect. Now what will be the derivative of v with respect to x? In this case, that will be equals to negative 10x So for the 4, that will be 0. And for the negative 5x squared, that gives us negative 10x. Perfect. Now we can now apply the product rule. So from product rule, it says that the derivative, the y dx, is simply equals to u times the v dx plus v times the u dx. So therefore, with the information we have, that is enough for us to substitute. Therefore, we have the y dx to now be equals to u, that is given as this. So we have 1 minus 2x squared plus 3x squared. Okay, now the v dx, we got that to be equals to negative 10x. So we are multiplying with minus 10x. Now the positive sign in the formula, we have it right here. And we have v, which is given as 4 minus 5x squared. So we have 4 minus 5x squared. And then the last one is the u dx. And we got that to be negative 2 plus 6x. Minus 2 plus 6x. Perfect. Now, to avoid a rough sheet or a rough work, let's get rid of some stops to have enough space. But we really don't need the question anymore. We can as well as get rid of it. So now we have the y dx to be equals to 1 minus 2x plus 3x squared, then multiplied by negative 10x, then plus 4 minus 5x all squared, then multiplied by negative 2 plus 6x. Perfect. Now at this point we can expand the bracket. Distribute these for this trinomial and we expand these two expressions. Now expanding them, negative 10 times 1 gives us negative 10x minus 10x, multiplied by minus 2x, we got positive 20x. And we repeat it for the last time, which is 3x squared, we have negative 30x to the power of 3. Okay, perfect. Now we have the positive sign, and I'm going to first, in the first place, put the expansion in the bracket. And later on, I will now use the positive sign to remove the bracket. Okay, now 4 times negative 2 gives us negative 8. And 4 times 6x gives us positive 24x. Perfect. Now, minus 5x squared times negative 2 gives us positive 10x all squared. And for the last product, 5x squared times 6x gives us minus 30x cubed. Okay, let me just put it that way. Perfect. So therefore, the y dx will be equals to minus 10x plus 20x minus 30x to the power of 3. Now let's use the sign to expand the bracket. So we have minus 8 plus 24x plus 10x squared, then minus 30x to the power of 3. Notice that the minus won't change the sign of any value. Okay, so this is equal. Now let's try and search for like terms. Okay, perfect. Now keep in mind this will be squared because this is minus 2x times minus 10x. That should be positive 20x squared. Okay, perfect. Now minus 10x then plus 24x, that gives us 14x. Then we have positive 20x squared, positive 10x squared. That gives us positive 30x squared. Now minus 30x cubed minus 30x cubed gives us negative 60x to the power of 3, and we have minus 8. And rearranging this, we have negative 60x to the power of 3 plus 30x squared plus 14x, then minus 8 to be our final answer. And that is the final solution to example number 2. If you have any question, feel free to let me know in the comment section below. So on to example number 3. consider the function y equals the root of x multiplied by 1 plus 2x all squared. So just like before, let u be equals to square root of x and v to be equals to 1 plus 2x all squared. Now, as you can clearly see, v is a function in the function. So the best thing we can do is to let w be equals to 1 plus 2x. So v can become w squared. So now we can determine the corresponding derivative. So the u dx will simply be equals, since u is the same as x to the power of half, then the u dx becomes 1/2 x to the power of negative half. So what I've done is that I've brought this to the front and then subtract 1 from it. Now this can be simplified forward to 1 divided by 2 with x. Perfect. Now what about the v dx? We can just determine the v dx straightforward, since it's a function within the function. But to determine it, we can just multiply the w dx by the v, the w. So what will be the w dx? Since w is equal to 1 plus 2x, then the w dx will be equals to 2. This is a constant, becomes 0, and the derivative of 2x gives us 2. Now what about the v, the w? Since v is equal to w squared, then differentiating it with respect to w gives us 2w. Now we can multiply them together right here in order to determine the v dx. And therefore we now have the v dx to be 2 times 2w. This gives us 4w. But w is 1 plus 2x. And so therefore we have the v dx to be 4 multiplied by 1 plus 2x. Perfect. Now that we have the v dx and the u dx, it's easy for us to determine the y dx. Okay, perfect. So let's write it somewhere beside it. Now we know that the y dx, it's equals, according to the product rule, is equal to u times the v dx plus v times the u dx. Now, since u is x to the power of half, then we have x to the power of half times the v dx. That gives us this. Okay, we are multiplying by 4 times 1 plus 2x. Perfect. Now the sign positive is there. Now what about v? V is entirely 1 plus 2x all squared. So we have 1 plus 2x all squared. And the u dx, we got that to be equals to this. And therefore we have to multiply by 1 over 2 with x. Perfect. Now to avoid rough work, let's get rid of all this. So now we have the y dx to be equals to, now we multiply this 4 and x to the power of half. We have 4x to the power of half multiplied by 1 plus 2x. Then we have the sign plus, then let's multiply these two together. That will become 1 plus 2x all to the power of 2, then entirely divided by 2 with x. Now let's try to combine this fraction by using this denominator to determine the LCM. So if the LCM, the y dx, becomes, if the LCM is 2 with x, then we have, if this is just a series divided by 1 in this, that gives us 2 with x, and entirely to be multiplying this. So therefore we have 4x to the power of half times 1 plus 2x times 2 with x. Then we have the positive sign plus, Now 2 root x into root x, that gives us 1, and 1 times this gives us 1 plus 2x all squared. Perfect. Now let's try and multiply these 2 and the 4 together. Good. Now we have the y dx continuation to equals to 8x to the power of half times 1 plus 2x, then multiply by root of x. I will write it as x to the power of half. Okay, then plus 1 plus 2x all squared, and entirely we have a division of 2 root x. Okay, so continuation. Now from indices, let me try and combine them first. We know that we can have it as 8x to the power of half times x to the power of half, then multiply by 1 plus 2x plus 1 plus 2x all squared, then everything is divided by 2 root x. Now these are of the same base, we can add the power, so we have 8x to the power of half plus half, then multiply by 1 plus 2x, then plus 1 plus 2x all squared, then we still have division of 2 root x. Perfect. Now simplifying forward, we have 8x, so we multiply in 1 plus 2x, and we have addition of 1 plus 2x all squared, and we still have a division of 2 root x. Good. Now proceeding forward, we now have the y dx to be equals, let's expand this likewise this. So we have 8x times 1 gives us 8x, then 8x times 2x gives us 16x squared plus 16x squared. Now let's split this into 2. We have plus 1 plus 2x times 1 plus 2x all divided by 2 root x. Now proceeding forward, we have 8x plus 16x squared plus 1 times 1 gives us 1. Since addition sign is there, let me just expand direct as it won't really change anything. Okay, that's 1. Then 1 times 2x gives us 2x plus 2x, and 2x times 1 gives us 2x plus 2x, then 2x times 2x gives us 4x squared plus 4x squared divided by 2 root x. Perfect. And then we have 8x. Well, let's just combine like terms first. Now 16x squared can be combined with 4x squared. Then we have 20x squared. Then 8x with 4x gives us 12x. Then finally it's just plus 1. Plus 1, then divided by 2 root x. And this will be our final answer to the problem. And that is the derivative of question number 3, or example number 3. So on to example number 4. So consider the function y that is equal to x cubed multiplied by 3 minus 2x plus 4x squared all to the power of 1 over 2. So feel free to pause the video and figure this out. Well, I changed my mind, so instead you have to use it as a practice problem. So you have to solve it and let me know your solution in the comment section below. Thank you. If you have any question, feel free to drop it in the comment section below. Thank you once again. Bye for now.